top, you have similar figures, and you see the little squiggle? That's your symbol for similar. Two equal signs and one squiggle is for congruency. This means similar. And by definition, similar figures have the same shape, but not necessarily the same size. So like a big rectangle and a little rectangle. Those would be similar. Same shape, different size. Big square and a little square. We already did that. Well, actually, we didn't really do dilations, but we're skipping past that one now. A big heart and a little heart. Those are similar. Okay. You have to meet two requirements to be similar polygons. Remember, a figure can have curves, polygons don't. You have to have congruent corresponding angles. So all the angles of one rectangle have to be congruent to all the angles of the other rectangle, which they are, because rectangles have what kind of angles? 90 degrees, so that's always going to work there. And then your corresponding sides have to be in proportion. Corresponding sides, that would be like the biggest side of one triangle to the biggest side of the other triangle, or the smallest side of one triangle to the smallest side of the other triangle. Corresponding sides, big to big, little to little. You wouldn't match up the biggest side of one triangle to the smallest side of the other triangle. That doesn't really make sense. Okay, so those sides have to be in proportion, meaning they have to have the same ratio. So if the ratio of the big sides is 1 to 2, the ratio of the smaller sides also has to be 1 to 2 so that they're similar. The similarity ratio, that is the ratio of corresponding sides. That's the ratio of corresponding sides. It's that 1 to 2 I was just referring to. Similarity ratio is the ratio of corresponding sides. Sometimes I say scale factor. It means the same thing. Scale factor and similarity ratio, it's the same thing. So your book, your worksheets, whatever it is, sometimes it will say scale factor, but they are the same thing. All right, numero uno. Triangle ABC is similar to triangle XYZ. Here's a similarity statement. See how we use our similar symbol? It works the same way as the congruency statements did back in chapter 4. The corresponding angles are lined up. So just looking at this statement here, angle A is congruent to which angle? X, because they're both in the first spots. Angle B would be congruent to which angle? Y. And C would be congruent to Z. Okay? The side AB corresponds with which side? XY. And the side BC would correspond with YZ. Okay? This thing will always be true if it's given to you. Sometimes the pictures get turned and flipped and rotated, so you don't always want to base it off the picture. You can, but it may not always be right. So, you have to fill in the blanks here. Part A, the measure of angle B is equal to the measure of which angle? Y. And the measure, or excuse me, part B, BC is to YZ as what is to XZ? AC. C, Colleen, the measure of angle A is equal to the measure of what? X. And then part D, BC is to YZ as what is to XY? AB. Congruent angles, sides are in proportion. Okay, they're not necessarily the same length, but they're always going to have the same ratio. Yes. Numero 2. Determine whether these parallelograms are similar. Well, they're the same shape. They say they're both parallelograms. And one's bigger than the other one. Good. Your angles aren't congruent. If the angles aren't congruent, they're not similar. Maybe you could find the other angle measures because you guys are geniuses and we just took a test over this. M would have to be 100 and D would have to be 120 because opposite angles are congruent. The consecutive ones, supplementary, so these are 80 and these are 60. So even when you have all four angles, you can still tell they're not congruent. Determine if they're similar. Not similar. Corresponding angles aren't congruent. Cool. Number 3. If triangles or any polygon are similar, then you can find the lengths of sides because all the sides are supposed to be in proportion. So if you have to find a missing side length and sides have to be in proportion, what do you have to set up? A proportion, a ratio, 2 ratios. I like to start with the unknown. So on number 3, it says if these triangles are similar, find the value of x and the length of AB. I like to start my proportions with the value I'm trying to find. So I'm going to pick x. X in that first triangle corresponds with which side in my second triangle? 50. So then x is to 50 as, now I have to come back. The only thing I have left here is 12. And does it go with 40? Yes. Make sure you double check with your congruency statement or similarity statement too. How do you solve a proportion? I don't have a calculator up here. So you can simplify first. 12 and 40 are both reducible by 4. So that would be 3 over 10. And I can do that math in my head. 10 times x is 10x, and 3 times 50 is 150. Divide by 10, and you should get x to equal 15. Now, if you have a calculator, you can just use your calculator, but some of us aren't fortunate enough, I guess. I'm just kidding. Then you have to find the length of AB. Put a y there. So you have a variable if you want. You can put in a variable if you're trying to solve for that length. Set up a proportion. Y in my first triangle corresponds with what? 30. As, now you have to come back. And you can either use 12 or you can use 15 because you now know x. I'm just going to stick with the ones they gave me, so I'll just do 12 over 40. 40y equals 360. Divide by 40. Should get y to equal 9. Similar figures, congruent angles, proportional sides. Questions on number 3. Okay, flip it over. And do number 4 on your own. Okay. For number 4, they tell us that the trapezoids here are similar, which means they have congruent angles, and their sides are in proportion. Emma, what did you get for the measure of angle H? Okay, look up here. H corresponds with which angle? L. Do you know what the measure of angle L is? So what's the measure of angle H? Nice. B, we have to find the value of x, which represents a side. Dawson, you got this? Is it 47? Sounds like a no. What did you do? Okay, good idea. You're finding a pattern, but these patterns won't be using addition and subtraction. You're going to be using multiplication and division to find them. Ooh. Right? You should see his face. That's what he's doing. So, Dawson, if I use the value of x, this side corresponds with which side in the other trapezoid? Which is, okay, equals, I have to come back here, and I get 42. And 42 corresponds with which side? 30. So now you have a proportion, and how can you solve that? Yeah, times that giant number. Okay, I don't have a calculator. It doesn't look like you have one out either right now. Okay, 6 goes into 30 5 times, and 6 goes into 42 7 times, right? Okay, so then I can take and say 5x is equal to 35 times 7. You agree? I still can't do that in my head, but I do know that whatever I get, I'm going to have to divide by 5. These cancel, so I get x. What's 35 divided by 5? 7. What's 7 times 7? There's your answer. You were really close.
You flipped 42 and 30. I did that first time.
Oh. You were answering someone else's question? Oh, okay. Val, what'd you get for the measure of angle D? 99? How'd you get that?
I did 180 minus 81.
180 minus 81?
Yeah.
Poor K.
That makes a straight line. A line.
Because they're what kind of angles?
Same side interior.
Good. How did you know these lines were parallel? Because it's a trapezoid, right? Good. And B is congruent to D. Nice job. All right. Questions on 4. Rashid, did you get those? No, I want you to go down and do number 6. How did we get C? Because this is a trapezoid, so the top and bottom are parallel, which means B and P are same side interior angles. So 180 minus 81 is 99, and then B is congruent to D. Number 6, draw your triangles. Kilgore. And then label it. So angle X is congruent to M, Y is congruent to N. Make sure you're using a different number of curves on each set. And then it says XY is 12, YZ is 14, ZX is 16, MN is 18, NP is 21, and PM is 24. Decide if they're similar. 2 requirements. The angles must be congruent, and the sides must be in proportion. I like to do the angles first. They're easier to see. Are the angles congruent? All right, so now we have to check if all the corresponding sides are. At the beginning, I said that's when you line up like big to big, little to little. So biggest side to biggest side. 16 over 24 reduced by 8. And what do you get? All right. Then you want to do little to little. 12 over 18 reduced by 6. 2/3. And then you have to check your last side. 14 to 21 reduced by 7. And you get 2/3. Since they all, bless you, have the same ratio, we would say they're proportional. Are the triangles similar? Yes, okay. So we're going to write a similarity statement because you're going to have to do this on your homework. Triangle XYZ is similar to, line it up. P. And then it says give your similarity ratio. On your homework, it'll say give the similarity ratio of the 2 triangles. What's our similarity ratio? 2/3. Are good? Okay. What, Sarah?
You always have to do like
Oops.